Hello everyone, we've been talking about Chapter 2 in A Student's Guide Through the Great Physics texts. This is a chapter on the life and death of a magnet. In the previous lecture, we talked about Gilbert's chapters 7 through 9, and in those we talked about specifically these figures like figure 2.5, where Gilbert explains how if you place a compass needle, or as he would call it, a versorium, near a spherical lodestone or a terrella, in which direction would it point? He also talked about what would happen if you were to break this terrella in half and place these magnetic compass needles inside of it, in which direction would they point. Let's go on to his chapter 10, in which he talks about the mutation of verticity and magnetic properties, or the alteration of the force awakened by the lodestone. In other words, he's asking, can a piece of iron be re-magnetized or have its magnetization changed after already having been magnetized? And in this chapter he argues that yes, it will retain whatever polarity it was last given by a magnet. So for example, if you were to take a rod of iron and you were to touch one end of it to the north pole of a magnet, that end would have a south pole, the opposite end of the iron would have a north pole. Then, if you take the first end of that iron and now touch it to a south pole of a magnet, it would reacquire a new magnetization and it would become the north pole of that piece of iron. And whatever you last touched it with, it would just stick. It would stay there. He also mentioned in this chapter that a stronger magnet will be able to more strongly magnetize a piece of iron. And he also mentions on the next page, we'll skip ahead to there, at the top of this page, page 26, he talks about even if you put a plate of gold or silver or glass between a magnet and that piece of iron, the iron is still magnetized through the gold or silver or glass. In other words, these magnetic effects that are transferred into the iron cannot be shielded by gold or glass or silver. Somehow it's able to go through that. Okay. He also mentions in this section that while iron can be easily remagnetized by a magnet placed near it, lodestones themselves cannot be remagnetized even by another more powerful lodestone. Why is this? Well, he says it is because the lodestone has this innate and ancient and long-lived property by virtue of it having been formed within the bowels of the earth. This is Gilbert's answer. So it's hard to change something that has been formed over centuries. Whereas with iron, because you're changing it very quickly, it can easily be changed itself. Now, I guess a more modern perspective on this would be to say that some magnetic materials have a low coercivity. That is, they are said to be magnetically soft. They can be readily remagnetized. Other materials are said to be magnetically hard. They are very difficult to remagnetize. They have a high coercivity. This is the way that we would talk about it now. And I guess a piece of iron would be comparatively soft and a lodestone would be comparatively hard. But in fact, there are magnetic materials that are even harder than lodestone. So if you took a neodymium magnet or a ferrite, a ceramic magnet, or a samarium cobalt magnet, those are very magnetically hard. They have high coercivity. They are very difficult to remagnetize, even compared to lodestones. We'll say more about this in a few minutes. What about chapter 9? In chapter 9, on page 26 here, he just mentions that the equator of a terrella, that is the equator of a spherical lodestone, if you rub it against a piece of iron, it is basically ineffective in magnetizing the iron. If you were to then take the piece of iron that you've touched to the equator of a spherical lodestone of a terrella, and you were to take this piece of iron and float it on a float, it wouldn't readily point toward the north or toward the south. That's the point he's making in chapter 11. And what about chapter 12? This is one of my favorite chapters in this section. He's talking about how verticity exists in smelted iron that is not excited by a lodestone. So what is he talking about? This is a fascinating chapter. He mentions that, sure enough, if you hold a piece of iron near a lodestone or a magnet, it acquires verticity. We know that. He's been talking about that for some time. But what about if you take a piece of iron and you smelt it, you heat it up in a blast furnace, and what happens, as he talked about before, is that it loses its verticity. It's unmagnetized after having done so. But then what happens if you cool it? What happens? You notice that it does acquire some verticity upon cooling. So there's a picture here that he gives. This is a smith heating up a piece of iron over a hot fire, and he mentions that when you cool down, after you've smelted it, heated up, it loses its verticity, and then you cool it down, it reacquires verticity in some cases, as long as you maintain it in the same orientation, that is, let's say in the north-south direction, while you're cooling it. And he says the verticity is reacquired from the earth. It's sort of frozen in from the earth while this metal is cooling. However, if you take it while it's cooling and reorient it east-west, north-south, and then reverse it again and again as it's cooling, then the earth will not be able to transfer its magnetic form to that piece of iron, and it will not be magnetized, or it will not have verticity after cooling. He says the magnetic form, if you keep it oriented in the same direction, is reborn, so to speak, after having been destroyed by the fire. This is on page 27 and 28, a really fascinating chapter. And he also mentions at the top of this some observations where even unmagnetized iron can acquire verticity after having been immobile for a long time, say for 20 years. He mentions here at the bottom of page 28, let us see also what position alone without fire and heat, and what mere giving to the iron a direction toward the earth's poles may do. Iron bars, he says, that for a long time, 20 years or more, have lain fixed in the north and south position, as bars often fixed in buildings and in glass window, such bars, in the lapse of time acquire verticity, and whether suspended in air or floated by corks on water, turn to the pole toward which they used to be directed, and magnetically attract and repel iron in equilibrium. For great is the effect of long continued direction by a body toward the poles. This, though made clear by plain experiment, gets confirmation, for what we find in a letter written in Italian and appended to a work by Master Philip Costa of Mantua, also in Italian, of the Compounding of Antidotes, which translated is as follows. And here is a story that this man talks about. At Mantua, an apothecary showed to me a piece of iron completely turned to lodestone, so attracting other iron that it might be compared to a lodestone. But this piece of iron, after it had for a long time supported a terracotta ornament on the tower of the church of San Agostino at Rimini, was at last bent by the force of the winds, and so remained for 10 years. The friars, wishing to have it restored to its original shape, gave it to a blacksmith, and in the smithy Master Giulio Cesare, prominent surgeon, discovered that it resembled lodestone and attracted iron. The effect was produced by a long continued lying in the direction of the poles. So in other words, if you have this piece of iron and you let it sit for a long time in the vicinity of the earth, which all iron is, then after a long period of time, the earth is able to transfer this magnetic form to the iron. That's the point that he's making here. All right, and there's one other thing that I think is very interesting at the bottom here. And here, if you read this, I'm going to go ahead and read this and see if you see what Gilbert is doing. Okay? He says, let me see where I want to start. For this reason, I'm reading at the bottom of page 29, for this reason it is not altogether superstitious and silly in many of our affairs and businesses to note the positions and configurations of countries, the points of the horizon, and the locations of the stars. For as when the babe is given forth to the light from the mother's womb and gains the power of respiration and certain animal functions, and as the planets and other heavenly bodies, according to their positions in the universe, and according to their configurations with the horizon and the earth, do then impart to the newcomer special and peculiar qualities, so, too, a piece of iron, while it is being wrought and lengthened, is affected by the general cause, the earth, to it, and while it is coming back from the fiery state to its original temperature, it becomes imbued with a special verticity according to its position. Notice what he's doing here. He's saying that iron, after having been smelted, as it cools down in the vicinity of the Earth, acquires magnetization from the Earth. And he says we really shouldn't be surprised by this. After all, we all know that when a baby is born coming out of its mother's womb, the relative position of the stars in the sky imprints some kind of character traits on this baby. This is basically astrology. And he's using astrology as a justification, or at least a way of understanding how this iron acquires its form in the similar way as human beings acquire their form from things around them while they're born, particularly the stars. Now, I'm not advocating astrology. I just think this is an interesting point to draw out in this scientific work where he's explicitly referring to astrology. Let's stop there. And what I want to do next time is talk a little bit more about the modern theory of magnetism and how it's similar or different to what Gilbert is talking about here.